Yeah.
We want to show that these two triangles are similar. Now, this is an example of something that I call a nested triangle because I've got one triangle, triangle MSN, which is completely inside the other triangle, MVT. And I wanted to ask myself, are these two triangles similar? When I have nested triangles like this, I find it to be a lot easier to kind of see what's going on if I pull the two triangles apart. So now I have MSN, which is, I'll call it my green triangle. And then I have MVT, which will be my red triangle. It's this whole big one. All right, so angle S was marked as being congruent to angle V. So I've got one pair of congruent angles that were marked here. Now, I know the side length of 9 and 5 that create that angle, so maybe I could do side angle side. But if I look at my big triangle, my big red one here, I do know this length from V to M would be 2.5 plus 9, so it'd be 11.5, but I do not have a length right here. So since I don't have a length right there, I cannot do side angle side. So that means that if I want to do if I want to show that these two triangles are similar, I would have to do it by angle, angle. All right, well, let's take a look at what angle pair might also be congruent. Angle M. When I pulled that triangle out, I just translated it, which means that it's rigid, the angle measures stay the same. So that angle M in my red triangle is the same as the angle M in my green triangle because it's literally the same angle. So this is something that we call the reflexive property. And I would love if you guys would write the reflexive property down on your right side notes right now. So at the top of your right side, write the word reflexive property. The reflexive property is basically tells us that any angle, or it also works with line segments, any line segment is always going to be equal or congruent to itself. So any angle or any line segment will equal itself. Write that down in your right side notes. So now if I look at my diagram, I have two pairs of congruent angles, which means I satisfy the angle-angle similarity. So I'm going to start by writing angle V, which I have marked in blue here, is congruent to angle S. Oops. So angle V is congruent to angle S. And then my other pair of angles that are congruent are angle M is congruent to itself, angle M. So this is where that reflexive property comes into play. Anytime you have nested triangles like we have here, you're going to usually be able to use the reflexive property to say that the angles are equal to each other. All right, well, I've satisfied my angle similarity condition. So that means that I can draw my arrows showing that these two fact bubbles can lead me to my conclusion. And my conclusion is that triangle VTM is going to be similar to triangle. If I started with V, the corresponding angle is S, so I have to start with S. For T, the corresponding angle is N, so N will come next. Sorry, my bubble wasn't big enough. And then for M, the corresponding angle was itself, so M. So remember, you get to pick the order you write your first triangle in, but then whichever order you write that first one in tells you how you have to write the second one. So triangle VTM is similar to triangle SNM. And then my reason for that is the condition that we just met, which was angle-angle similarity.